All right, so here we've got a messier rational. Instead of having 0 on one side, we have an expression. So let's start analytically. We will look at minus x over x plus 3, creating a situation with 0 on one side. First thing we want to do is create a common denominator. So let's do that. X squared minus 1 and x plus 3. Okay, in this case, you need now to expand your brackets. X cubed plus 3x squared minus 4x minus 12 minus x cubed plus x over x squared minus 1, x plus 3. Okay, we're getting closer. And then x cubes are going to cancel. You end up with 3x squared minus 3x minus 12 on the top, and x plus 1, x minus 1, x plus 3 on the denominator. Factor out the 3, x squared minus x minus 4, x plus 1, x minus 1, x plus 3, and factor the top, x minus, oh, that's not going to factor nicely, is it? Okay, so that we're going to need a bit more work on. We're going to need the quadratic formula. So we bring that in. X is minus b, so minus minus 1, plus minus the square root of b squared, minus 1 squared, minus 4. A is 1, and c is minus 4, over 2 times a. So 1 plus or minus the root of 1 plus 16 over 2. Okay. Now we've got quite an interesting number line. You have to look at minus 1, 1, and minus 3. Those are the division by 0. And on the top, you have 1 plus root 17 over 2. So that's about 5 over 2, 2.5, somewhere over here. 1 plus root 17 over 2. And then you have 1 minus root 17, so 1 minus around 4, 1 minus 4, minus 3 over 2, it's somewhere in here. Okay? Okay, so those are our 1, 2, 3, 4, 5, I don't know, either asymptotes or zeros, x-intercepts. Now we have to get to the work of figuring out where this thing is true. So let's take negative 10. When you look at negative 10, you're going to get negative 10, 300 plus 30 minus 12. So that's going to be positive. The top will be positive. And negative 10 will give you negative times negative times negative, which is negative. So 3 negatives and 1 positive is negative. And we're interested in that part of the graph. Then something between these, you could pick negative 2.5. So negative 2.5, oh gosh, this is going to be messy. So picking each of those regions and going through and solving each of them is a time-consuming process, but I'll let you do that because otherwise this vodcast would be far too long. But pick a point, test it, 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 pick a point, test it. Okay? So that is an example that analytically gets quite challenging. When you look at it graphically, it's also challenging. However, we can break it down into pieces and figure this out as well. If I'm looking at my graph, notice I have the left-hand side and the right-hand side always with my denominator and my numerator in brackets. Okay? That's given here. Now, I want to know where this is less than this. It's obvious over here that both graphs go on forever, and this one is always higher value than this one. So when we trace and we come over, notice these values here help you. We see that we are on the graph x squared minus 4, and it is below this graph. You see? So this graph is below that graph, which is exactly what we want. So it concurs with our beginning of our analytic method. Now, there's a value here, an asymptote, right, at -3. Okay? After you cross that asymptote, you can see that the graph of x squared minus 4 over x squared minus 1 is suddenly above the graph of x plus 3. That's not what we want. We want it to be below. So we're not going to shade in this region. How do I find this exact value? Analytically, I found it, but I can use my calculator to calculate number 5, the intersection, and press enter, enter, enter. And it will find this value, which will give you the same as this. Okay? Then, as you're going across, you can start to see that this one, x over x plus 3, is suddenly higher. Okay, that's what you wanted again. So we're going to shade that region. So in here, it's also true. Up until the value of -1. At -1, you see there's also a division by 0. No. Yes. Okay. So, okay. At this point, it's getting pretty messy in here. I'm not totally sure what's going to happen between -1 and 1, and all I know for certain is that I want y4 to be less than y5. Okay, again, it's getting pretty cluttery, so something else we can do is we can check the table, and I'm interested from -1 to 1, so I'm going to start at -1 and count in halves, and then I'm going to look at the table. Remember, what we want is for y5 to be bigger than y4. So this one is not bigger, this one is not bigger, not bigger, not bigger. So up until the value of 1, between -1 and 1, we're not interested in that region. Then, above 1, suddenly this y5 is bigger than y4. Okay? So therefore, we are interested in this region here. Okay? And again, we can come back and look, okay, well this was the solution to where it was 0. So we can go back to the graph again and focus on this here. We calculate the intersection. We want to move over. Again, notice these numbers at the bottom. And that's what we want. Enter, enter, enter. So the decimal 2.56 is the equivalent to this exact form. And then we want to come over from that point and look over here. Okay, so we can just trace, go over, and the curves change. So at this point, we can see that the curve that's lower is x over x plus 3, which is this one, which we don't want. So our final answer is everything, x less than -3, x is between this exact value, 1 minus root 17 over 2, or to 3 significant figures is also acceptable. And we want everything between 1 and 1 plus root 17 over 2.